Moving to the next question. Among the four elements which is given to you, A, B, C and D, their atomic mass is given to you and their atomic number is given to you. You have to identify the isobar combination. What are isobars? Going back to the definition to revise for you students. Isobars are atoms of different elements having same mass number but different atomic number. Now between A, B, C and D, the four elements which are having the same mass number, students, look and tell me, come on. A third standard student will tell me that C and D both are having same mass number 22, 22. So C and D are the isobars, and which is the choice? Choice C is the correct answer. Okay, moving to the next question. Which of the following statement is not correct regarding electromagnetic radiation or electromagnetic spectrum? Which of the following is not a true statement, or which of the following statement is not suitable? The velocity of X-ray is more than that of microwave. Next, infrared radiation have larger wavelength than cosmic rays. Next, the frequency of microwave is less than that of ultraviolet radiation, and X-rays have larger wave number than microwaves. Come on student, which of the following properties, which is the correct answer? A is the correct answer. The velocity of X-rays is more than that of microwave. You can get from the electromagnetic radiation spectrum diagram, you know the value and you can decide from that. So for that you have to know the values of wavelengths of different radiations of spectrum. Moving to the next question. The kinetic energy of the ejected electron in a photoelectric effect is, according to Planck's quantum theory and photoelectric effect, what is the relation between kinetic energy and wavelength? Kinetic energy and wavelength are directly proportional to the frequency of the incident radiation. That means kinetic energy is directly proportional to what? The frequency nu of the ejected electron. So choice A is the correct answer. Moving to the next question. Photoelectric effect is not observed in case of. Photoelectric effect is not observed in which of the following elements or metals? Magnesium, you don't see it in magnesium, but you see it in potassium, rubidium and cesium. Yes, it is not observed in the element magnesium. Choice C is the correct answer. Moving to the next question. Atoms cannot give you which type of spectrum is not shown by atoms. Band spectrum is not observed in case of atoms. So choice C is the correct answer. Next question. If RH is the Rydberg's constant, then the energy of an electron in the ground state of hydrogen atom is given by what? Now what is the relation between Rydberg's constant and energy? We know that 1 by lambda is equal to Rydberg's constant RH inside the bracket 1 upon n1 square minus 1 upon n2 square for hydrogen atom. Because there is only one electron, there is only one electronic shell. So for hydrogen atom, it will be the choice D, which is the correct relation between Rydberg's constant and the frequency. Moving to the next question. Bohr's model of an atom can explain the spectral of all except. Bohr's atomic model is an atomic model which explains the atomic spectrum of hydrogen and similar type of species. Hydrogen and similar type of species means what? All species having one electron. You will see in the choices, helium has how many electrons? Helium has 2 electrons. So Bohr's atomic model does not explain the atomic spectrum of which atom? Helium. Whereas rest of them, it will show, H will show, He plus will show, and Li plus 2 will also show, because they are losing electrons and getting only one electron in the positive state. Moving to the next question. According to de Broglie's concept, the circumference of an orbit which must be equal to, according to de Broglie's relation, according to de Broglie's equation, the circumference must be equal to what? Circumference of an orbit must be equal to what? The integral number of electronic wavelength. The integral number of electrons wavelength. Yes, that is according to de Broglie's relation. Moving to the next question. Which one of the following atomic orbitals is not directed along the axis of rotation? Which one of the following atomic orbitals is not rotated or directed. You see that dxy is not directed any directions of axis of rotation. Next question is, the electronic configuration of an element chromium is given as 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 5, 4s1. This is the electronic configuration of chromium because half-filled orbitals are more stable than incompletely filled orbitals. Based on that stability, this is the ground state electronic configuration of chromium. So the correct answer is choice B. Yes, students? Okay. We are seeing the questions are very easy. We are solving the questions easily because our concept is clear. And if your concept is very clear, students, you will be able to solve the questions so smoothly, so easily, just by applying the concept, applying the formulas and doing the proper calculations. Moving to the next question, an atom chromium has 1 4s electron and 5 3d electrons. How many unpaired electrons would be present in chromium plus 3? That means the configuration is what? It is 3d5 4s1. 3d5 4s1. When it goes into plus 3 state, that means the 5 unpaired electrons, 3 are lost. So what are remaining now? 2 are remaining. 2 from 3d and 1 from 4s. So total unpaired electrons will be 3. Correct answer is choice C. Moving to the next question. FM radio broadcasts at 900 kilohertz. What wavelength does this correspond to? You have to find out the wavelength. Frequency is given to you. According to de Broglie's relation, we know that. What is the relation? C is equal to nu lambda. C is equal to nu lambda. Nu is the frequency. Yes. C is the velocity of light. Find out lambda. So lambda will be equal to C upon nu. So you know the velocity of light is 3 into 10 raised to 8 meters per second. Convert kilohertz to hertz. Convert kilohertz into hertz by dividing by 1000 or multiplying by 1000. You will multiply by 1000. So kilohertz will become hertz. Substitute the value of frequency, substitute the value of velocity of light or speed of light, and then find out the wavelength. The correct answer should come in terms of meters, that is 333 meters. Understanding, students? So we are using de Broglie's relation and coming to the correct answer. Remember the relation, C is equal to nu lambda. Moving to the next question. A wavelength of 400 nanometer corresponds to. Now wavelength is given to you, lambda in terms of nanometer. Convert the nanometer in terms of meter. 1 nanometer is equal to 10 raised to minus 9 meters. So multiply 400 into 10 raised to minus 9 will be what? 4 into 10 raised to minus 7 meters. We have converted the wavelength. Now we have to find out whether the wavelength is matching to the frequency. So how will you find out frequency? Nu. Nu will be equal to C upon lambda. C is the speed of light or velocity of light, 3 into 10 raised to 8 divided by lambda, 4 into 10 raised to minus 7. So you will get the frequency. Then you will get the wave number. Wave number is nu bar. Nu bar is equal to 1 upon lambda. Find out the wave number. That will give you the correct answer for the wave number. And then you find out the momentum. Momentum is equal to mv. So lambda is equal to C upon mv. So mv will be equal to C upon lambda. So using de Broglie's relation, we see that A, B, C, D can be determined and all the answers of frequency, wave number and momentum are matching in the given choices. So all of the above is the correct answer. Yes, students. So this example is a very good example, students. It has helped you to calculate 3 things using de Broglie's relation. It has revised the formula for you.